draw the function y equals 2 tangent of x minus pi over 4. So the first thing that I'm going to do is I'm going to determine what kind of transformations this does and what the original function is also. My original function is y equals tangent of x. If I ignore all the numbers just like we did before, I would end up ignoring this 2 and this minus pi over 4, so I would get y is equal to tangent of x. So what I'm going to do is, or what this function does, is it's going to have a shift to the right of pi over 4, and it has a stretch on the y's of 2. So let's go ahead and start with the original tangent function. So this is y equals tangent of x, and then I'm going to start with the points negative pi over 4, negative 1, 0, 0, and pi over 4, 1. So these are the basic points that we came up with when we were graphing the tangent function. So that's these points right here. We're going to do shifts on these points as well as a vertical asymptote. So let's go ahead and write out the vertical asymptotes as well. So vertical asymptote is negative pi over 2, and the other vertical asymptote is at pi over 2. Now for the first transformation that I'm going to take care of, it's tangent of x minus pi over 4. So this tells me that I'm going to go to the right by pi over 4, which means I'm going to add a pi over 4 to each of the x values, but the y values are going to stay the same. So the vertical asymptote, because these are x values, those are going to change as well. So the vertical asymptotes are going to change, and we're going to add that pi over 4 to each of them. So for the first one, we're going to get 0. For the second one, we're going to get 0 plus pi over 4, that gives me a pi over 4. Then pi over 4 plus pi over 4 gives me 2 pi over 4, so that gives me a pi over 2. So for the first one, it was negative pi over 4 plus a pi over 4, that's what gave me that 0. Now what I'm going to do is I'm going to take the negative pi over 2 and I'm going to go ahead and add a pi over 4. So this gives me back a negative pi over 4. So pi over 2 plus pi over 4 is going to give me a 3 pi over 4. So now I'm going to take care of the stretch on the y's. So this is y equals 2 tangent of x minus pi over 4. So now what this tells me to do is multiply the y's by 2. So I'm going to take the y's and I'm going to multiply them by 2, or 2 times the y's. So that means that the x's are not going to change, so 0, pi over 4, and pi over 2 are going to stay the same, as well as the vertical asymptote, because those are x values. So x equals negative pi over 4, and x equals 3 pi over 4. Now for the y value, I'm going to multiply them by 2, so negative 1 times 2 gives me back a negative 2. And then 0 times 2 gives me a 0, and 1 times 2 gives me a 2. So then these are going to be the new points that I'm going to go ahead and plot. So let's go ahead and graph the function. So for the tangent function, we're going to go ahead and start at negative pi over 4. So I'm going to go ahead and draw a scale going by pi over 4. This is negative pi over 4, this is 0, this is pi over 4, this is 2 pi over 4, or in other words, pi over 2. This is 3 pi over 4, and that was the last asymptote that I had. And because I'm going to draw it over one period, I'm actually just going to draw it between negative pi over 4 to 3 pi over 4. So as long as I use the basic points starting from the original asymptotes and then make the transformations on them, I will still be able to draw it over one period, which means it's over a distance of pi. So same thing here, this is over a distance of pi. So let's go ahead and draw the asymptotes, or the new asymptotes. That would be at negative pi over 4 and at 3 pi over 4. So my new points are going to go through 0, negative 2, and the highest point is going to be at 2 also. So let's go ahead and draw the y scale. So this is 1, 2, this is negative 1, this is negative 2. So again, there's a stretch going on the y-axis, or on the y values. So 0, negative 2, that would be this one. And then we have pi over 4, 0, and then we have pi over 2, 2. So we're going to go ahead and graph our tangent function approaching the asymptotes and also going through those points. So this would be the tangent function with these transformations. So 2 tangent of x minus pi over 4. Let's go ahead and do another example. So let's go ahead and graph now. F of x is equal to cosecant of x minus pi over 2. So for cosecant of x minus pi over 2, what we're going to do is we're going to use the cosecant function. So we're going to use this graph right here. So we're going to use this idea. We first drew the original function or original reciprocal. So then the original function was sine of x, and we draw the sine of x first and then draw the cosecant on the maxima and the minimum of that sine of x. So this function tells me that I'm going to take the cosecant and I'm going to shift it to the left by pi over 2. So we can take the cosecant function and then we can shift all of the points to the left, or we can start with the sine function, make the transformations on the sine function, and then go ahead and use that to graph this right here. So you have 2 different options here. So let me go ahead and graph it with the sine function since we already know how to do transformations. For the transformation, it tells me go to the right by pi over 2. So then I'm going to take this, move it to the right by pi over 2, take that, move it to the right by pi over 2, take the second asymptote, move it to the right by pi over 2, take the point, this point, and move it to the right by pi over 2, take this one and move it to the right by pi over 2. So instead of doing that, what I'm going to do is first figure out the original function. So my original function is y equals cosecant of x. We'll now figure out where cosecant of x comes from. Cosecant of x comes from the sine of x function. So y equals sine of x. So cosecant is a reciprocal of sine. And now what I'm going to do is I'm going to do the transformation that I have here, but on sine of x. So y equals sine of x minus pi over 2. So this tells me go to the right by pi over 2. So I'm going to take my original sine function and my basic points, and I'm going to move them to the right by pi over 2. So if I graph the sine function, if you don't have the points memorized already, you would use the sine function. This is 0, 0. This is pi over 2, 1. And then this is pi 0. This one would be 3 pi over 2, negative 1. And the last one would be 2 pi 0. So I'm going to shift it to the right by pi over 2. So that means that I'm going to go to the right pi over 2. The y stays the same. Pi over 2 plus pi over 2 is going to give me pi. And this should be a 1. And then pi plus pi over 2 gives me 3 pi over 2. And the y value is going to be 0. So the y values are basically staying the same. So let me go ahead and write out the y values. So the next one is going to be 3 pi over 2 plus pi over 2. That gives me a 4 pi over 2. So that gives me 2 pi. And the next one is 2 pi plus pi over 2. So that gives me a 4 pi over 2 plus pi over 2. So that gives me 5 pi over 2. So now I'm going to graph this transformed sine function. So what I could do is, oh, and by the way, on this one, you could have used transformations, or you could have used this procedure that I showed you guys earlier. So you could use this if you wanted to. So you can use a phase shifting if you want to determine what this function would look like. So let's go ahead and use the transformations to draw the sine function. So we're going to go through pi over 2, and I'm going to go ahead and go by pi over 2. So this is pi over 2. This would be 2 pi over 2, so that's pi. This is 3 pi over 2. This is 2 pi, and that's 5 pi over 2. So then I'm going to go ahead and start graphing my sine function, starting at pi over 2. At pi we're at 1, because there's no stretch on the y's. And then at 3 pi over 2 we're at 0, at 2 pi we're at negative 1, and at 5 pi over 2 we're at 0. So then graph your sine function, but this isn't the function that I was trying to graph. I'm going to use this though as reference for my cosecant with this transformation. So remember that wherever it crosses the x-axis, as long as it doesn't have a shift going up or going down, this is going to be my asymptote. So this one's going to be an asymptote, this one's going to be an asymptote, and this one's going to be an asymptote. So x equals pi over 2, x equals 3 pi over 2, and x equals 5 pi over 2 are my asymptotes. I'm graphing it over a period, over one period, so the period is equal to 2 pi. So we're graphing it over a distance of 2 pi. Now for the maximum, I'm going to go ahead and draw what looks like a parabola facing up and going through pi 1. I'm going to do the same thing for the minimum, and I'm going to graph it facing down, again going through 2 pi negative 1. So this is pi 1, and this is 2 pi negative 1. So this in blue is my transformed cosecant function. Again, what you could have done for the cosecant function is you could have taken this 0 and then you could have shifted it to the right by pi over 2. 0 plus pi over 2 gives me a pi over 2. Take this pi over 2 comma 1 and shift it to the right by pi over 2. That means I add a pi over 2 to this pi over 2. So that gives me a pi. So at pi we're going to be at 1. So you do the same thing for the asymptote. The next one, pi plus pi over 2 gives me 3 pi over 2. 3 pi over 2 plus pi over 2 gives me the 2 pi. And then 2 pi plus pi over 2 gives me 5 pi over 2. So you could have just taken this and then shifted it to the right by pi over 2. So let's go ahead and do one last function. So f of x equals 2 times secant of x. So this is a pretty simple function or transformation. So this is, again, f of x equals 2 secant of x. And for 2 secant of x, the only difference between this one and the original secant of x is that we're going to take this function and we're going to have a stretch on the y's. So this point was 0, 1. This point was pi negative 1. So this was 0, 1, and that was pi negative 1. Instead of being at 0, 1, now it's going to be at 0, 2. So basically we're going to multiply all of those values, y values, by 2. And this one, instead of being at negative 1, now it's going to be at negative 2. So we'd have exactly the same function, just now at oscillating above the 1, above the 2, and below the negative 2. Alright, so 2 secant of x is going to look like the following. So again, secant of x function comes from y equals cosine of x function. If you need to, go back and draw that cosine of x function. So I'm not going to label the y-axis just yet because I do want to change that to 2 and negative 2 at the end. But let's go ahead and graph the cosine of x function. Cosine of x goes above, and then it goes back down, and then it goes back up. We know that our asymptotes are going to be where it crosses the axis. So this would be at x equals pi over 2. And this would be at x equals 3 pi over 2. Because we only end up with one piece, we want to make sure that we have 2 pieces for the asymptote so that we can draw the 2 pieces for the secant of x function. We're going to go ahead and extend it to the left side, and we're only going to really need everything up to this asymptote at x equals negative pi over 2. So we're going to go ahead and graph between these two and also between these two, pi over 2 and 3 pi over 2. So on the maximum, we're going to go ahead and draw what looks like a parabola facing up, and on the minimum, draw what looks like a parabola facing down. But now the y values are not 1 and negative 1 as they would be for the original cosine function. Now they're going to be at 2 and negative 2. So then the graph for 2 secant of x goes above the 2 and below the negative 2. So at some point I started talking about the ranges for the cosecant, the secant, and the cotangent. So for the tangent, let me talk about the tangent function. For the tangent of x function, we had we had range of negative infinity to infinity. So we've already talked about domain. We're going to talk about range for a second. So negative infinity to infinity. So if you notice, this points down all the way down, and this points up all the way to infinity. Now for the cosecant of x function, or the cosecant of theta function, we had, let's see, cosecant of x, it says that you go between negative infinity to negative 1, union 1 to infinity, and the 1 and the negative 1 are included. So if you notice, again, this function, this middle one, is a sine function. It was just a reference, so only the blue and the pink are part of the cosecant function. So it's including everything above it, including the 1, so this piece is included, and it's including the negative 1 and everything below. Everything between negative 1 and 1, so this piece right here, is not part of my graph. For the secant function, it's going to go between negative infinity and negative 1, union 1 to infinity, include the negative 1, include the 1. So then nothing in between the negative 1 and 1 are included for the secant function, but everything above the 1 is included, everything below the negative 1 is included, which means that the range is going to be 1 to infinity, negative 1, or negative infinity to negative 1 also. So that would be this one. And for cotangent, we had a range that went from all the way to the top to all the way to the bottom, or in other words, all the way to the bottom if I start on the bottom side, to all the way to the top, which is infinity. So negative infinity all the way to infinity.